Hi everyone, welcome to another video. We are looking today at doing some exact values questions. We're going to be working through just 3 questions in this video. And what we're going to be doing is we're putting together the 2 ideas we learnt in this series, which is exact values as well as obtuse angles. So you can see for some of these questions, I've included a couple of obtuse angles. And this is going to A, help us revise what we've learned in obtuse angles, and B, see how we can relate what we know about exact values and these exact value triangles, how we can relate these 2 topics together. Now, just as a little recap, we looked at 2 exact value triangles here with these ratios, 1, 1, root 2, as well as this one. We had 1, 2, root 3, and we had 30 degrees and 60 degrees. Okay, so in essence, this first question, kind of just a little recap of what we were doing before. So now that we've drawn our exact value triangles, this becomes quite easy to do. We want to locate our angle of 60 here, and we want to find what the ratio is for cos. Now, from SOHCAHTOA, our cos links the adjacent and the hypotenuse together. So we want to first label our triangle. So we have the adjacent, we have the hypotenuse, we have the opposite. And we just want to identify what the ratio will be. So the cos of 60, that's going to be equal to the adjacent over the hypotenuse. Now my adjacent is 1, my hypotenuse is 2. So that is it for this question. We're given an angle and we have the exact value triangle, so we're pretty much just reading off that triangle, making sure we're picking the correct sides to set up this ratio here. Okay, that was a little warm-up question, but let's look at another one here. Now this is going to be a little trickier because now we're looking at these obtuse angles. So it's going to be a recap of what we did before. And I'm going to do this by first drawing my little semicircle here and having the portion of my unit circle. Remember, a unit circle just has these ratios of 1. Sorry, these distances of 1. So if I want to find sine of 150 degrees, I'm going to measure an angle of 150, which is going to be kind of like there. And I'm going to draw out my relevant right angle triangle in my second quadrant here. So I have a right angle triangle. I have an angle sum of 150, and that means that my angle here that I'm looking at is 30 degrees. Okay, now we can also think of this based on what we learnt in the videos on obtuse triangles, where we said sine of theta equals to sine of 180 minus theta. So, since we're doing sine of, we've got sine of 150, so the 180 minus theta here, that thing has to equal to 150. So what value of theta is what's essentially being subtracted from 180 in order to give me 150? Well, my theta here is going to be 30. So that kind of makes sense. So I have sine of 30 degrees equals to sine of 180 degrees minus theta. Oh, sorry, minus 30. Or in other words, the sine of 150. So we're kind of reverse engineering this, but it's still following as it would for our regular, just looking at this through a unit circle. Okay, so now we've constructed, if I take this triangle and I pull it out of my unit circle, I make it a bit bigger so we can work through with it. I have, whoops. Sorry, these are shocking triangles, but just bear with me. Now I have a triangle with a right angle triangle with 30 degrees here. Now, all angles on a triangle add up to 180, so this one's going to be 60. And this triangle looks kind of familiar. That is this one on the right here. This is an exact value triangle that I've made in my unit circle. So let me just go ahead and label that. So the side opposite 30 degrees is going to be 1. The hypotenuse is going to be 2. Hypotenuse is 2. And this side is going to be root 3. We can double check that. The side opposite 60 degrees is root 3. Side opposite 60 degrees is root 3. Beautiful. So now I'm essentially looking for sine of 30. Now with SOHCAHTOA, the sine of 30 degrees is equal to the ratio of my opposite over my hypotenuse. My opposite is here. Whoops, no it's not. My opposite's here, my hypotenuse is here, my adjacent's here. So I'm looking at the sides of 1 and 2 here. And that's what I'm going to substitute in. So my sine of 30 is going to be my opposite 1 over my hypotenuse of 2. So we're applying, now we're pulling information from what we know about obtuse angles, and we're putting it all in and looking at how now we can find exact values of obtuse angles, something like sine of 150 degrees. So we're actually doing quite a bit here, and this is all very new, but it all makes sense if we approach it from different ways. We can either use our trig ratios we know, we can even draw this using my unit circle on the right. Now let's do one more question. We have tan of 135 degrees. So let's draw in another unit circle. I have y, I have x, and I have this guy here. 1, -1, and 1. Now I'm finding the tan of 135 degrees. So that is going to be, if I measure this angle, it's going to be kind of there. Let's actually try again. It'd be about here. So this is an angle of 135 degrees. And I'm going to draw this line out to meet the edge of my circle here. So let's have a look. So I've drawn this out and I have my right angle here. So my angle in here is just going to be 180 minus 135 degrees, which gives me 45 degrees. And I can basically just write out in the same way what I know about my trig identities. So tan of theta equals to, well, negative tan of theta is going to equal to tan of 180 minus theta. Because remember, when I do this, I'm looking at something in the second quadrant, in which my tan ratio of a positive y over a negative x is going to give me a negative answer. Okay, and I can figure out what this theta is. I've already done that, but I can think of, well, what subtracts from 180 to give me 135? That's going to be 45. So minus tan of 45 equals to tan of 180 minus 45. Okay. Sorry, I know that's a little bit messy, but let's now draw my unit circle. Well, I've drawn my unit circle. Let's take this triangle out and draw it here. So I have my really nice isosceles triangle with 45 degrees and 45 degrees. And the tan of that, well, it doesn't really matter what these sides are. Now, if I draw my regular exact value triangle, like the one I have over here, I get something that looks like this. And I can find the tan of 45. So, the tan of 45 degrees is equal to my opposite. Now, it doesn't matter which one I choose because they're the same. But let's say we took this to be theta. This guy here is going to be my opposite, my adjacent, and my hypotenuse. And my tan ratio is my opposite over my adjacent. So I have here 1 over 1, which gives me 1. But we are in the second quadrant, so my tan is going to be negative. So all of these become negative. And that is my answer to this one. Now, just a little side note. Some of you may be thinking, well, we said this is a unit circle, so shouldn't this be 1 and not root 2? You're absolutely right, and we're going to get into this a lot later. But remember, these are ratios, and the ratios work for similar triangles as well. So we have 1 here. These two lengths, this one here and this one, if we scaled this triangle here, if we scaled this guy down a little bit, instead of being 1, 1, root 2, we scaled it down, we would still get the same ratios happening. So it doesn't matter what the lengths of this and this are. Since both of these angles are 45, these sides are going to be equal. So this side and this side, these sides are equal. Because remember, when we have a certain angle size, if the angle opposite a side is one thing, and we have the same angle opposite another side, those angles are equal, so the sides opposite those will be equal too. And anytime we take a ratio, and we can do this with either the 45 or the 45 here, but opposite over adjacent will always give me one of these green sides I've labeled over another one. And since they're the same, it doesn't matter if this is 1 over 1 or half over a half or 3 over 3. The ratio is always going to be 1. Hence why we get 1 as an answer for tan of 45. Now, the only kicker here is that we're looking at an obtuse value of 135 degrees. So this tan is in the second quadrant here. We have my first quadrant and we have my second quadrant. So tan is going to be, I'm going to have a positive over a negative. That is always going to give me a negative answer. And our trig identity that we talked about a couple of videos ago shows me that exact same thing. That brings us to the end of the video. Thank you so much for joining me, and I will see you next time.